today's assignment, I mean, it's the same thing. So it's the same, it was the same notes. I'm just showing you some different problems, especially ones like this first one right here. You'll see this kind of stuff on SATs and ACTs. Okay, so usually the problem will just have the sentence and that's it. So what we know is that we've got this triangle with these vertices. I already graphed it to save time. It says, what are the coordinates of the orthocenter? So to be able to do that, you need to know that the orthocenter was perpendicular from the corners. In other words, from this corner right here, it would be perpendicular to this line over there, okay? And from every corner. Let me get rid of that. Okay, so it would be easiest with this particular one to just go perpendicular from the corners. So if I'm going perpendicular to this line, remember when we did perpendicular slopes. So this slope is up 1, 2, 3, 4, and over 1. So my slope is 4. And if I want a perpendicular slope, the perpendicular slope, remember we have to flip and negate. So that means I'm going to flip this to 1/4 and make it a negative 1/4. I wrote that wrong. Okay, so for this slope, I got to go from this corner and it's a negative 1/4. So that means I got to go up 1 and left 1, 2, 3, 4. Up 1 and left 1, 2, 3, 4. Okay, so that'll be my first line. So I'll make it blue. I'm going from this corner to here. So this would be an altitude. Okay, so that's going to be an altitude. It's perpendicular to this line. It's from that corner. All right, next I'll do red. I'll go from this corner to this line. So I need to find this slope, which is up 1, 2, 3, 4, and left 1, 2, 3, 4. So up 4 and left 4. Left always means negative, is really a negative 1. So if I want the perpendicular slope, I have to flip it and then negate it. So it's just going to be a positive 1 over 1, which is just 1. So from here, I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Okay, so next I'll make a red line from this corner through these points. So this is going to be the altitude for that one. So anytime you need to make an altitude, that's what you're looking at. You're going from the corner and you got to get the slope, the perpendicular slope of this line. So my last one, I'm going to go from this corner, which means I need the slope of this line. This slope is going to be up 0 and over 1. So anytime you have 0 on top, that's really 0. So you can't really flip it. If you flip and negate it, it's going to look like this, which is undefined. You cannot have 0 at the bottom of a fraction. So an undefined slope is really a vertical line. Okay, so this one, I don't even really need to make dots. My vertical line looks like that. So if I make a line, make it purple, I'm going to go from here. So this is all 3 of them. Really, you only need 2 because wherever the 2 cross, the third one inevitably is going to cross. So that they want to know what are the coordinates of your orthocenter for that one. Your coordinates are right here. This is my orthocenter where all 3 lines cross, and that is 2, 1, 2, 3, 4, 2, 4. Okay, that is a very difficult problem. You're probably not gonna see that too much on a quiz or test for me, but you might see it if we have to take the SOLs. That's the kind of thing they'll put on there. I know it's difficult, but that's what it's going to be, okay? And you might see them on SATs and ACTs. So if it's orthocenter, you just have to kind of know your vocab. We need to know that that means it's the altitudes, which means it's perpendicular from the corners, okay? Next, for triangle ABCD, this is a little easier. So this kind of thing you'll see a lot of. They want to know if it's a median, an altitude, or neither, okay? So altitude, we just said. Altitude is from the corner, and then it's going to be perpendicular to the side. Okay, median is going to be from the corner, but it's going to cut the other side in half. So those are kind of your vocab words. So altitude, I already gave you a million times. This is from a corner to the side, and it's perpendicular to the side. Okay, this one, median. The median is from the corner to the midpoint of the side. So if I'm looking at AD, AD goes from a corner, and then it goes to D right here, which is right in the middle. So since it's in the middle, this is going to be a median. And then it does say explain, so you can just say it goes from a corner to a midpoint. EG, right here, it is in the middle. E is in the middle, but G is not from a corner. So this is going to be neither. And then you could just say not from a vertex. I think you will see some like this on the test, on the unit test. And then if you look at CF, CF goes from a corner, and then it's perpendicular to the side over here. So this is going to be an altitude. And then that's just corner to the side, and it's perpendicular to the side. Okay, I gave another SAT one, difficult one like this. So coordinates of the circumcenter. So when it's a circumcenter, you just have to know your vocab. So in this case, it has to be from, it must be perpendicular, and it must be from the midpoint of the line. So that's the difference. So both of those, the orthocenter and the circumcenter, they're going to have perpendicular lines. The orthocenter comes from the corners, but the circumcenter comes from the sides. So it's going to be from the midpoint of the sides, which means you need to find the midpoint, which is why I keep making you find midpoints on the weeklies. You have to be able to do that to do the difficult stuff. Okay, so I've got my coordinates. I've got, oh, I'm writing everywhere. Okay, so I've got 0, 0. I've got 0, 1, 2, 3, 4, 5, 6. And I've got 1, 2, 3, 4, 0. So this is my triangle. And then I'm supposed to find the intersection. So I'm basically supposed to find the circumcenter, find the coordinates of it. Okay, I have a little hint here that it's easiest to find the perpendicular bisectors of the vertical and horizontal lines. It's much easier to find those, okay, as opposed to doing the middle of that line right there. So you can tell that the midpoint here is right there. Okay, so if we're going from 0 to 4, it's right there. If you need to do the midpoint, you can do the midpoint. So we can add up 0 and 4 and divide it by 2. So it's going to give you 2. 0 and 0 divided by 2 is going to be 0. So 2, 0 is the midpoint right there. If I need to do the midpoint of this line, this vertical line, that's PO. So 0 and 0 cut in half is 0. And then 0 and 6 cut in half is 3. It's not really necessary for vertical and horizontal lines. You can tell right where the middle is. Now, this one, you'd be guessing a little bit more. So if I had to do the midpoint of that for P and S, I'd have to do 4 and 0 and cut it in half to get 2. And then I'd have to do 0 and 6 and cut it in half and get 3. So 2, 3. These are the midpoints of my 3 lines. So I have to go from those points to be able to find my circumcenter. So I'm supposed to do the perpendicular slopes from that. Okay, so for this one, for example, this slope, you go up 1 and over 0. So this is undefined, which means obviously perpendicular to vertical is going to be horizontal. So that would just be a horizontal line right through this. Okay, and if it's horizontal, then perpendicular is going to be vertical. So it's got to be vertical through that green dot right there. It's really hard to write on this. Okay, and then for this one, my slope is up 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4 to the left. And then, so to get the perpendicular slope for that, you would have a positive 4 over 6. So from that dot, it doesn't matter which direction you go. I can go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6. Or you could have gone down 1, 2, 3, 4, 2, 3, 4, 5, 6. Okay, and then you can make your segment there. Oh, I missed it. I didn't draw it the rest of the way. There we go. Okay, so those would be my 3 different perpendicular bisectors. Notice they don't go through the corners like the orthocenters did. Okay, so they just kind of go through random points otherwise. So the 3 places, the places where the 3 cross are right here. And again, I didn't even have to do this one right here. If you get 2 of them, the place they cross is going to be what you're looking for. But I like to do the 3rd one to make sure and double check. So it's going right through that dot, all 3 of them. We've got 2, 3. Okay, so those are very difficult. That's why I showed you 2 of them. but you might see stuff like that on SATs and ACTs. These two, I added two. This is the stuff that we were doing yesterday. I wanted to do two more because these are the ones that we see the most of. Okay, so this, especially for me in my class, these are the ones we're doing the most of. So in this case, this first one was the easier one. This is the one I'm really talking about. So this one over here, it's showing that these things are all equal. So all three of them have these marks, which means I'm just going to set these two equal because they both have x's. I'll stay away from the y's for a second. Okay, so I've got the 7x and 4 and the 9x minus 2. So subtract the 7x, add the 2. So that's going to be 6. Now, to be able to figure out the y, it's equal to both of these, so it doesn't matter which one you plug that into. We're going to plug it in. So I've got 7 times 6, which is 42, and 4 is going to give me 46. So that means I can take 5y and set it equal to 46. So if I divide by 5, that's going to give me, hold on. Yes. So if I divide by 5, it's not going to work out that nice. It's going to be 9.2 or 9 1/5. Okay. All right. Next, I'm going to be doing this one. So I need to find what x, y, and z is. So in that case, I've got these ones from the corners to the midpoints. Okay, so that's what the 2/3 thing that we were doing yesterday that I was harping on. So pick a corner, go to that point of concurrency. There's 24. That is always equal to 2/3 of the whole thing. Now the whole thing is 24 and 6z. Okay, so you can distribute if you want, or you can multiply by the reciprocal if you want. It doesn't really matter. I'm just going to distribute. You do it however you want. And then I'm going to subtract the, that's 24, that's fine. I'm going to subtract the 16 from the 24 and get 8. So z is 2. Moving on to another corner. So pick a corner, go to the point of concurrency. That one right there is 3y and 5. So that always goes alone. Whatever that measurement is, it goes alone. On the other side, you get 2/3 and you have to find the whole thing. So I've got 3y and 5 plus 10. I can't fit it. Okay, now that'll just give me 15 right there. So I really got 3y and 15. Okay, so I got 3y and 5 on this side. 2/3 times 3y is just going to give me 2y. And 2/3 times 15 is going to give me 10. So subtract the 2y, subtract the 5. Finally, go from your last corner to right there to the point of concurrency, and that's 2x. So that always goes alone. And then on the other side, you get 2/3 of the whole thing. So the whole thing is 2x and 12. Okay, so whatever you want to do, I'm just going to stick with distributing. So that's going to give me 4/3 and 8. Okay, so if I subtract the 4/3 from 2, that's going to give me, that's actually going to give me 2/3. And then from here, you can either divide by 2/3 or you can multiply by the reciprocal. Either way, it doesn't matter what you're going to do, you're going to get 12. Okay, yes. Okay, so I just wanted to go over one more of those. And just a heads up with the ones like this, usually you're going to set things equal to each other with those. Okay, the last thing I told you about was I was going to show you an example that goes like how each one is used in real life. Okay, so they use a lot of this kind of stuff for amusement parks to make things convenient. So a lot of engineers use this kind of thing. Okay, so for every 3 rides, he's going to make a garbage can. So to make it the easiest, he's going to use the circumcenter of the 3 rides. So you have ride number 1 right here, ride number 2 here, and ride number 3. So you've got your 3 rides in the corners. And then they want to put a garbage can in the middle of all of them. So they want to put it equidistant from each one. So it's for it to be equidistant from each ride, you find the circumcenter. Because from the corner, this is going to be equal to this, and it's going to be equal to this. So it's going to be the same distance. So a lot of engineers use this kind of stuff. Okay, in center. So if we're doing a triangular countertop, you might see things like this. It just has one post underneath the entire thing on top. Okay, so countertops, This works for things, people that are going to be building things. So a lot of engineers and whatever, but people that build things and are going to be, I can't think of the word. I can't think of the word when people redo houses and whatnot, but that's what I'm talking about. And then he wants to move the stove to the in center of it so that it's an easy access from all sides. Again, it has to do with being equidistant from sides or equidistant from certain angles. So he uses the in center to put the stove in the middle so it's equidistant from the sides, because the in center comes from the sides. The three sides are equal. Okay, the one we were doing up here, it was equidistant from the corners. So if you have three different things and you're trying to find the equidistant from those, use the circumcenter. If you want it from the sides of different things like this, then you're going to have to use the in center. Okay, so in center from all the sides of the counter, that's going to be the equidistant part from all the sides. Okay, centroid. Carpenter is making, this is the table that I was talking about with the one leg. So if he's gonna, this is the centroid is the center of gravity. So he's gonna make a table with one leg. He uses the centroid because it'll be the center of gravity. Okay, so this right here, it'll be a perfect balance. So it's not gonna be kind of the center. You think of something as the center, but it's gonna be a perfect balancing point. So everything will balance perfectly on that one point right there. And finally, orthocenters. This is talking about hang gliders. So hang gliders are the people that you have that triangle kind of thing behind you and you're holding on to the post. You're basically flying like on a kite is what it is. So it's going to glide itself. The glide itself will be an obtuse triangle. So the glide is kind of like basically what you're flying on, the kite. And he uses the orthocenter of the glide. So that'll be outside of the triangle. So this is the glide. This is the thing you'll be hanging on to hang glide. He's got the dotted lines because that's outside of the triangle. So this is going to be your orthocenter, and it'll make sure that the cord's descending down from the glide to the rider. So you have the hang glide, and then you have these cords and whatever attached to the hang glider, to the person that's doing it. Okay, they are even length. We want them to be even, and they're connecting to this one point of concurrency. That's where the person is, the hang glider is. Okay, so all of these cords are attached to your hang glider equidistant. Okay, so that's kind of how they're used in life. A lot of engineers, a lot of things that get built are used with this. Okay, so today's assignment is kind of similar to yesterday's, it's just longer. A couple different types of problems in there as well. So good luck. Let me know if you need any help. Shoot me an email. Have a good day.